Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about FaradayRF, amateur radio with digital data. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CacheFly.com.
This is FLOSS Weekly with Randall Schwartz and Jonathan Bennett. Episode 436, recorded May 30th, 2017. FaradayRF. This episode of FLOSS Weekly is brought to you by Bitbucket from Atlassian. Bitbucket is the Git solution for professional teams. Start your free account today at bitbucket.org/forthecode. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at StoneAge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and not actually even aware of it, projects you might want to download right after the show, or in this case, you might want to order right after the show if you happen to be of a particular kind of person who's playing around with amateur radio. Joining me this week, once again, welcome back, Jonathan Bennett.
Hey, Randall, good to be here.
Good, good. And where are you speaking to us from? Your typical flyover place somewhere?
Yes, the flyover place. Corporate headquarters, as I call it, the home office here in Lawton, Oklahoma.
And I am back in beautiful gray. Unfortunately, I thought I was going to say sunny Santa Monica, but it's gray Santa Monica today because they have this thing around here called June gloom, where pretty much for the entire month of June, or at least most of it, it's overcast every single day. It might burn through later in the day, but I'm not counting on it. I'm glad I brought my long sleeve shirts because I'm going to need them every single day these 2 weeks that I'm going to be here. They've upped the bandwidth, though. It looks like we got a terabit now into the home office here, or the ZipRecruiter. So I'm thinking of downloading the entire internet later this week. So that'll be fun. Anyway, so this week
your hard drive is full. Please insert a floppy disk.
Yes, right. Absolutely true. Hey, so you brought this show, actually, we have FaradayRF on today. You brought this show to us. Can you describe a little bit of what this is all about?
Sure. So I have done what a lot of hackers that have some interest in radio have done. I got my ham radio license, and I bought one of these, a little cheap Baofeng radio, just enough to get you started. And I looked at it, and I went, it would be great if you could do something digital with this. And I said, well, I've also got a Raspberry Pi. Can I make these two talk to each other? No, you really can't. And then I was on, I believe it was Hackaday, one of the websites that talks a lot about hardware stuff. And these guys got featured there, and they were doing basically the way to make something like a Raspberry Pi talk to a radio to be able to do digital communications. And so it really piqued my interest. And one of the first things I did, it's about the same time as when I started doing FLOSS Weekly. I reached out to them and I said, hey, would you guys be interested in doing a FLOSS Weekly interview? And they said, yes, but not right now. We're crazy busy. So I've been bugging them about once a month ever since then for about a year now. And finally, we got the date put together and got them on the show today.
Awesome. And by they, we mean, let me look at the names here, Bryce and Brenton Salmi, who I thought initially were just brothers, but it turns out they're twin brothers. So this is even more awesome. I believe it's a first for our show. We've first set of twins actually on the show. So that's going to be amazingly awesome. I know almost nothing about amateur radio. My dad was big into that, but that was a long time ago. My grandfather actually was also huge into amateur radio. But this is putting a whole new layer on it. This is actually putting digital communications over the top of the radio. So rather than just people speaking to each other, we have actual data, because data is actually cool. Because you can always do voice over data, but it's hard to do data over voice, except if I just sit here and say 1, 3, 3, 5, 1. That's pretty useless. Anyway, so let me go ahead, though. We're going to bring them on in just a minute, but I do have an important message before we do that, because this episode of FLOSS Weekly is brought to you by Bitbucket. Let's be honest, your code is your world. You create it, tweak it, and lovingly obsess over it every day. So picking the right repository management tool is super important. Only the best for your code, right? That's why the team at Atlassian created Bitbucket. Bitbucket is the Git solution for professional teams. It helps over 5 million developers build with a purpose. Bitbucket gives teams of all sizes free private repositories with state-of-the-art features. The world's best pull request algorithm. Pull requests facilitate code reviews. You can collaborate right in the code with inline comments, threaded conversations, and mentions. Built-in continuous delivery. Branch permissions help prevent errors by controlling the actions users can perform. You get granular permissions at the project, repository, or even the branch level. Also integrations with your favorite tools like Docker, AWS, and Azure. Because Bitbucket comes from Atlassian, it offers the best Jira integration available, giving your team everything you need to take your code from concept to customer. More than 900,000 teams love Bitbucket. It's used by companies like Ford, PayPal, Starbucks, and Pandora. It's the only collaborative Git solution that massively scales. Bitbucket is for the code that takes us to Mars, decodes the human genome, or drives your next car. Visit bitbucket.org/forthecode to start your free account. That's bitbucket.org/forthecode. Try Bitbucket today. What will your code do? And we thank Bitbucket for their sponsorship of Floss Weekly. So let's go ahead and bring up our first guest. Both of our guests. Let's bring up Bryce first. Bryce Salmi, welcome to the show.
Hi. How's it going? I'm Bryce Salmi, KB1LQC.
Very cool. And where are you speaking to us from?
I'm from Los Angeles, California. So
okay, cool.
Right down the street,
cool. Just down the street. Yes. And then let's also bring on Brenton Salmi. Brenton, welcome back to the show. Welcome to the show, I mean, not back.
Hey, how are you?
Although somebody watching the video might think I just invited the same person twice, except you change your shirt in between the two.
I'm really fast.
This is very cool. Oh, no, we put both of you on at the same time, so now they'll know. So let's go ahead and get started. Bryce, why don't you give us the overview? What's the 30,000-foot view here? What is it? What problem is this thing solving?
So FaradayRF is solving the problem of providing a open source digital communications solution that is low cost infrastructure and also appealing to not only image radio operators but the maker community in general. So trying to blend those two those two groups together, because we actually have a lot in common, and this is just really allowing people to be creative with image radio from a digital perspective.
Okay, and so how did you get involved with this?
I've been an image radio operator since 2004. So I've gone through the gamut of contesting, Morse code. Actually, my first conversation ever was on a home-built Morse code transmitter with like the random piece of LAN cable soldered together as transmission line. It probably shouldn't have worked, but it did, and I started off that way, and eventually got more and more into experimentation. And ever since college with K2GXT at the Rochester Institute of Technology, have really started working on projects and bringing in amateur radio as a means to do cool projects from with technology, going more and more digital. So led to Faraday.
So I want to jump in with a question, if I can. What the name FaradayRF? Where does Faraday come from? Is that a reference to Michael Faraday? Tell us a little bit about that.
Yes, it is. Yeah. So we kind of were throwing around names, and for a while this project didn't even have a name. And what we ended up doing was we looked and said, well, Michael Faraday came up with the basics of electromagnetism, those laws. So we're like, all right, well, our first radio, let's do Faraday, and and then we decided, well, we'll name it FaradayRF as a company, and it stuck.
So you guys have it's a piece of actual hardware, right? The actual Faraday board. What exactly does it do? Does it have the radio built into it, or does it just convert from audio to digital? Tell us about the board.
So here's the board. I don't know if you guys can see it. There we go.
Perfect.
Let me get. It's a little light. There we go. Oh, nope. Okay, so
left is right.
That's it. Yeah, right. So what Faraday is it's an all-in-one hardware-defined radio solution. So we decided to go with a chip called it's a Texas Instruments CC430. It's essentially an MSP430 with a CC1101 chip radio in it, all in one. And it has an integrated radio and microcontroller on board, as well as USB serial connectivity and power supplies on board with an RF amplifier to actually put out about 400 milliwatts of power, all in one board. And most of our boards come with onboard GPS for location awareness as well. So we provide the all-in-one package, so you don't have to cobble together power supplies and radios and go back between the radio like you held up, Jonathan, in the beginning. So it's all in one package, and you can develop for it over USB. And yeah, it's providing that all-in-one solution.
So it's got a microcontroller built into it. How is that locked down, or is it programmable? Does it need to have something like a Raspberry Pi to work?
Nope. So actually, you can see on the back there's pads for a JTAG connector. So we can use JTAG to program it. Also, we do have a bootloader as well, so we can program it for the most part over USB. And if you want to do debugging, you need the JTAG, but that's all accessible on the bottom. And it does not need a Raspberry Pi to run, although at one point we would like to hook it up to one, because we can access external SPI ports and actually command it over SPI. So that's kind of in the books. Sometime we'd like to do that. But it is an all-in-one smart node. Like you can set it out and tell it to do things on its own. To what the power of an MSP430 will do. Our main goal there is low power and easy to program. The documentation for MSP430 series of microcontrollers is really good. So and we're familiar with it, so we went with it. And the fact that you don't need to power it with a large battery, it'll last. We haven't even optimized for power yet in the code. It doesn't even go into low power modes, and on a 9-volt battery, we'll get easily 10 hours out of it on full power at like 1 hertz data. So it's, we kind of looked at that and said, all right, let's wipe our hands for now, focus on some other stuff, and we'll come back to the power later. But we didn't want to have to lug around big batteries or a power cable as well.
So what you said, we can program the microcontroller. Is it just assembly? Is there a C compiler for it? What all does that involve?
So programming for MSP430 is in C, and so you can use various tool chains. You can use MSP GCC, although we haven't really done it. There's a few, I think, peculiarities. Maybe Brent can offer insight into those. He does more of the C programming for the project at the moment, but we tend to use CC Code Composer Studio to program from a TI, and yeah, you just program in C. And it uses their libraries and stuff, which are largely open. I'm not sure if they're open source. Brent can answer to that one.
So I was going to ask, how does the breakout work between the two of you, Bryce and Brenton? Who does what? Let me know who I should be asking which questions to. Brenton, go ahead and jump in.
Sure, I'll jump in here. Bryce and I jump between doing the hardware and the programming, both on the software side from a Python perspective and a C side on a firmware. I tend to do a lot more firmware on the MSP430. I think it should be noted that when you program for Faraday, there's a firmware side where we're programming the actual chip on board, the actual MSP430, and there's also a Python side, which is on a computer, if you have it hooked up to a computer, so that you can actually do more intensive processing applications that we've done above what an MSP430 can do. There's a whole Python side, and that's actually the main part of the project is to develop in Python. But yes, right now we use Code Composer Studio mostly for C. And on Python side for the computer, Bryce and a few of our contributors have taken the reins on the Python side for the most part on the project.
Okay, so what can we, if someone buys one of these, what can we accomplish with them? What kind of a range are we talking about? And do they mesh? Can we have a whole bunch of them saturate a community?
So from the right from the get-go. We have been focusing on point-to-point communications at the moment. Our end goal, if you read our master plan on our website, our end goal is to expand the infrastructure, one of our goals. And so we do want to do more of a hub and spoke type network. And we're getting there. We're very close to that. But for the most part, we can achieve most of our software development at the moment by just focusing on point-to-point. And from that aspect, we have done line of sight tests actually across I think it's the Santa Monica Bay is the one right by LA. So we put up a base station antenna in Palos Verdes, California, and then we drove along the coast. And actually, as I was driving my car up the up the coast, right at Dockweiler Beach, which is about 10 miles away from where we put the antenna. You can read this on our website. The RF just dropped out. It's 400 milliwatts, and that's about 10 miles. And we got really confused, and we kept driving, and then we realized, oh wait, that's the horizon. 10 miles away, my car went below the horizon, and at 900 megahertz, 33 centimeter handband, you're very susceptible to horizon, because our base station was only about 60 feet above the ocean, so not too far. So then I drove all the way in LA traffic, so about another hour and a half, to Malibu, and actually kind of found my way on the Pepperdine University campus, and just kept going up their hill. They have a huge hill, and at about 600 feet above elevation, above the sea level, I ended up popping above the horizon, because my horizon at that point was, I think, something like 30 miles, and we just instantly gained communications, and we had the 1 hertz telemetry. So we achieved 24 miles that day. So that was line of sight, awesome. Now, if you have lower towers, like if you put one of these base stations at 100 feet above the ground, or 50 feet or 20 feet, say on your house, then you will have smaller range, because it is susceptible to the horizon. However, we are trying to make these as inexpensive as possible and as open. So we hope more people will build hardware and figure out how to get this cheaper. But we want to make it such that we don't need to put these really expensive transmitters on the top of mountains. We can actually kind of distribute it. And we don't currently do mesh networking. We focus on hub and spoke. At least we're going to be focusing on kind of a hub and spoke infrastructure at first. Mesh kind of has a whole new level of problems to solve when you do that.
So you mentioned again about the open source nature of this. It seems like your firmware is open. The Python libraries you're building are open. What about the hardware itself? Is it also an open hardware?
Yeah. So all the hardware files are on our GitHub. We have a GitHub hardware repo on the FaradayRF GitHub's organization website, and it is licensed under the Tapper version 1.0. So it's a ham radio group called the Tucson Amateur Packet Radio. I forget the R. Radio, that's it. Yeah. Tucson Amateur Packet Radio Group. Wow, that was weird. But it's kind of like the CERN. There's a few differences from the CERN open hardware license, but so that is fully open source. You can download not only the schematics in KiCad. We use KiCad to do the hardware, but it's also, we put the Gerbers and we put the bill of materials up there, so anyone can go and essentially and produce the hardware. Or take it and change it. And the software is GPL version 3, so firmware and software. And our take on the hardware, from some people, get into the weeds of, is the chip open, right? But if you look into how integrated circuits are made, they're extremely expensive, like billions of dollars to make a chip, often. So it tends to be really hard. There's a few people trying to do it now open source, but kind of our take is, if you don't need to sign an NDA to get the data sheet, it's probably good enough for open source hardware from our perspective. So you can learn all about as much as you can about the chip and actually learn how to implement it. So we didn't kind of restrict ourselves to things where it had to be like a totally open source chip.
Maybe one of these days, RISC-V will be mature enough that we can rebuild it with that.
Maybe.
So I want to ask a little bit about licensing, not software licensing, but FCC licensing. Mm-hmm. Does someone have to have a ham license to be able to use this? And what level of license does one have to have?
Brent, you're welcome to chime in here on this one if I leave anything out. But you do need to have an amateur radio license, a technician class. So the first class, like the easiest one to study for and get to operate this radio. So you're operating under FCC Part 97 regulations. So a little bit of a bump, but it's really easy to get that license. And it's worthwhile because the benefits you get from having a license, the ability to build your own hardware that has radios in it and operate them, is I have yet to run out of things to do in the hobby after, what is it, 13 years now? 13 years. So I'm still finding new and interesting applications. And, at this point, I'm obviously making my own.
Every time I've looked at getting into amateur radio, I always think, oh my God, that's another thing that's going to take all my money and all the time I don't have. So I've completely never succumbed to the temptation. I had occasionally thought about it though. It's back in the day.
Maybe we can push your luck.
No, I don't need another expensive hobby. Truly. I do enough things already. I mean, I had to give up flying small planes just because I had no time and no money, but I've flown 270 hours in the left seat. So instrument rated high performance, retract, the whole thing. And I just had to kind of set it all aside about 15 years ago because I just didn't have time to get back to it. Snowboarding, same way. I used to be snowboard all the time. And where did all those time go? I think it's because it was back in the 90s. I actually had spare time because I had 5 people working for me, training people in Perl, and I was just making money hand over fist, and I blew it all. I'm broke again, working for a living, just like everybody else is now. Anyway, so I was curious now. So we have you've got radios at both ends, and you're doing probably frequency shift keying, FSK.
It's GFSK right now, but the CC430 is capable of several different modulations. Right now, we're just using Gaussian frequency shift keying. It's a pretty standard modulation out there used in several even ham radio applications.
Okay, so that's nothing new. That's not the new technology you're bringing to this, but then you're putting some sort of wire protocol over the digits that are being transferred back and forth. What protocols are you using? IP?
Yeah, so that's a great question, and this really gets down to the fundamentals of what Bryce and I believe. How this digital problem within ham radio should be approached, and it should be approached in our belief as simply as possible. Right now, we have developed actually very custom, very simple and focused on educational value, simple network stacks for both the serial USB and the RF side. It's extremely simple. It basically has there's a physical layer that is handled by the hardware, and then we have a data link layer, a MAC layer, and a very simple transport layer, just so we can get bytes, packets back and forth between different applications. And it is extremely simple, so that we can show so we can also learn and develop, because Bryce and I are hardware engineers by trade, so we're learning the software and network developing as we go. I've never had a formal class in this, so this is very much a fun endeavor for us. Where that simple nature comes in from an educational value is that learning things like packet encapsulation, automatic retry request, and error detection, and putting all of that together into different in applications is where we can start to have that educational value for the digital communications in ham radio and just digital communications in general. So when you go and you have like an ISM, when you compare ISM versus ham radio, and you say like, where do we fit in there? We fit in right in the middle, where right now we're developing the very, very simple network stacks to build our base technology and build those applications that we can do in ham radio, but also be able to show in an easily progressive fashion, this is how you understand networks. This is how you transfer data in ham radio. Hey, if I want to send a file, I've learned how to frame data and make a little ARQ protocol and actually transfer files and data through my own radios, which is something that is either handled by a Zigbee or other ISM band digital radio all for you, or you have to go figure that out. And we're right in the middle there, where we are we're making a very educational network stack. But in the future, we definitely see IP and that whole stack forming within Faraday as well. But right now, we're keeping it very simple.
Aren't there other radio pairs or radio systems that already do IP over amateur frequencies?
Yeah, there's, from a ham radio perspective, there's you have D-Star is one that a lot of people will talk about. It's very hotly contested whether or not it's open. It's within the ham radio community. That's kind of a hot topic to some people. But that will do TCP/IP. But the main goal of D-Star, what it was designed for, was voice, so digital voice, not necessarily digital data. you have to go very high in frequency and you get very expensive hardware, thousands of dollars to do the digital data aspect of it. And that will do TCP IP over ham radio. And then you have a lot of the ISM solutions, like Ubiquiti makes these great little bullet type radios that you can shove a lot of data down over some long haul link, and that works. But it is you're dealing with this very big the IEEE 802.11 or 802 series protocol that is a huge, very large amount of information to digest. The firmware may not be available to you. You may not be able to pick through it and figure out how it works. So we're really trying to provide that educational value of if we're going to have a successful ham radio future with digital communications in it, we need to not only provide a solution, we need to help provide a means to educate people and give them the tools necessary to learn how to develop in the future even better networks. Make the cost of learning lower. That barrier.
Okay, and so do you see this mostly as just something you're doing for your own hobbying and maybe educational purposes at some point, or do you see some sort of practical outcome to the technology you're building?
Yeah, it's so right now this is our thing we do at nights and weekends when we're not in our day jobs. But the sorry, just getting over sickness here. And it's definitely, it always, has been and will be a fun aspect to it. We did start our FaradayRF as a company to help, really build this out and, provide hardware for people. But in the future, we do want to expand the network and actually provide, start with cities, provide a amateur radio network that people can experiment with, use, send things like digital voice or digital data, situational awareness perspective of data over this network, and actually use it to do things that we currently already do in ham radio, digital voice and like situational awareness, APRS, if people have heard of that, over it. But also new things like sending large amounts of data. We always toy around with the idea of one day having a satellite that has, say something like this on it, and you can have a remote node in the desert somewhere or in the woods, and you can remotely command it somewhere. Like, that's not really done much in ham radio, but it's within reason to think that we should be able to build something like that. I mean, that's kind of really far down the road, but we really want to expand that ability to be creative with the hobby and not just do the same thing we've always done.
How many channels can you fit in the band, this 33 centimeter band that you keep talking about? Can hundreds of different people be using these channels at the same time?
Bryce, can I take this one?
Oh yeah, totally.
Please.
Yeah. So it's a little bit of a hard question to answer because there's no specific channels, but we have a band that we've built Faraday for, which is the 33 centimeter, and that's 902 megahertz to 930. I'm blanking on it. I think it's 28 megahertz wide, and you can Faraday with the CC430 chip can go up to 500 kilobits per second of raw baud rate. And I'm blanking on how much bandwidth that is, but that is the largest bandwidth, and so it'll be a couple hundred kilohertz, or maybe a little bit more. Or you can go down. You can really fine tune and slow the speed down so that you can go longer range. You have a better signal to noise ratio, and you can squeeze that bandwidth down to 1200 baud if you really wanted to, and then you could fit a lot more stations in there. But 28 megahertz in the large part is a gigantic band. It's also one of the reasons that we chose 33 centimeter band. Rather than, say, the 70 centimeter band, which most people probably would have thought would have been a little bit more obvious. 33 centimeters is a relatively unused band in ham radio. It is unused largely because voice communications has been a predominant part of amateur radio, which is great, but 33 centimeters has a lot of line of sight issues, some noise issues. It's not conducive to analog voice as much as it is to digital data, which has error correction, detection, and can retry packets and make that a seamless experience. So 33 centimeters and up really, they're larger bands. You can fit more stations in there. and they're very conducive to digital networks. Hope that answers your question.
I think so. Go ahead.
Yeah, I can also expand on that. The CC430 is capable of doing spread spectrum, so you can do frequency hopping to fit people in. You can also do time division multiplexing. So we can, in the future, leverage some of those technologies to either share time on a channel or share frequency, and that actually helps us fit in more people there too.
Yeah, it's exactly my next question, because I'm familiar with how Wi-Fi works and how it actually bounces all over the band that's allowed for it. So that in case there is a dropout, it's only dropping out at one point, and hopefully they don't randomly jigger at exactly the same time. So it sounds like that's a good way to go. Now, since you're going to be doing digital voice, what about, there's obviously you're going to have to retry packets from time to time. Does that add a bit of jitter to the conversation, and is that noticeable?
So right now we haven't actually sent digital voice over. I've sent files and data. We're right now we're in the core technology building phase of the project, where we're expanding our ability to develop faster and better with our community, and we're also figuring out bugs within the hardware and firmware. And so digital voice is probably within the next month, 2 months at most. We're actually pretty close to it, but again, I think Faraday should be looked at as a platform, not necessarily a single solution. So we're learning and experimenting just as much as the people who have purchased and are also playing around with our radios. So to say whether it'll have like a jitter or anything else, I can imagine that Faraday will work just like any other digital network, where if there's a sufficiently low amount of packet losses, you might not even notice at all, maybe a little jump here or there, but it is a digital network, or it's a digital protocol at its core, so it's going to act like one. And we'll have to see where we go within these next couple months, and maybe there'll be just a straight up streaming digital voice protocol, which is probably the most realistic short-term goal. And if we throw in error correction and maybe even forward error correction, maybe that would be a better seamless experience. But yeah, it's right now. I think we should shy away from viewing Faraday as a completed solution on the digital voice, and it's more of a platform where we can experiment with all of these technologies.
And so it says people should be experimenting with this. What's been the uptake? Have you had a number of people interested in contributing back?
Yeah, so we currently have 9 contributors on the GitHub repository who've contributed code. There's a few really prominent ones. I think like Riley has really helped us a lot. I've learned a lot from him because again, Brent and I are hardware engineers by day, so learning a lot about the software aspect. There's a few others on there as well. So it's been neat to start building an open source community. It's not something neither of us have really done in the past. So that is growing. We've seen a few drive-by Git commits as well, which has been fun. From a radio perspective, there are currently 28 radios out there being used. In 8 different states. So that's pretty cool. One of the people who's contributed, Eli, has yesterday just did a range test. If you look on Twitter, you'll see some of it. We use the FaradayRF account to communicate back and forth, and they were trying some range testing in Arkansas. So yeah, the more radios we have out there, the more people that we can get feedback from. One of our main goals one of the reasons we actually pushed off this podcast for so long, when Jonathan kept asking, was because we needed to get the hardware out. Producing hardware is really hard when you're manufacturing many of these radios, and trying to get them right and verify that when you send something to a person, it's going to work. So we did that and shipped it for our first radios in February, and that's when we saw an uptick in just us making progress. So once we had people using these that weren't familiar with how the code is written or weren't familiar with the hardware, we could see the problems and the sticking points that instantly allowed us to go and fix those things and try to make things easier. And that's been really the focus that we've had in the last couple months.
And are these frequencies also available internationally?
So 33 centimeters. I think it's available in Canada as well. one of the more popular questions we get, especially on Twitter, is I wish you guys had a different band, not 33, because most good amount of countries in the world don't support it. So that was an honest choice on our end. The main reason being it is relatively unused in America from a ham perspective. It is small antennas, and we have from a regulatory perspective for ham radio Part 97 rules, we can do much faster modulation, much faster much more bandwidth on 900 than say on 400 megahertz. So we chose 900 because it allowed us the most freedom as well in smaller antenna sizes. And we really would like to expand and go say higher or lower in frequency with different hardware in the future to allow other people in other countries to use these. But it's kind of our perspective that we kind of learned from our day job is keep everything simple. Like, we don't want to get bogged down in supporting multiple different radios, producing multiple different types of hardware right now when we have so much work to do on the software and firmware perspective.
Right.
And just even from an infrastructure, how do we set up a city? How do we set up long haul? At some point, do we want to provide communications from LA all the way up the coast to San Francisco or something? Those are things we need to figure out, and spreading ourselves too thin can get dangerous. It can make things slow down or even just fail. So that is one reason we haven't jumped in that. But it is open source, and I often will tell people, hey, like, take the schematics. If you're familiar with hardware, like, go switch out the chip or switch out the amplifier for a different band in the filters, and it should just work. Our software is frequency agnostic. It doesn't actually care what frequency you're on. So it's just the hardware that's kind of limiting at the moment for that.
Are you low power enough that you could power it from, say, a large battery and a solar panel?
Well, it works for about 10 hours right now on a 9-volt, so it's pretty low power. It's powered completely from USB when you plug it in. It will default to a battery if you plug a battery in until the battery drains down, and then it will switch automatically over to USB if you kind of it plays nicely between the two power sources. Yeah, so you don't even need that large of a battery. I mean, the larger battery you put on it, the longer it'll last. And we designed it to take up to 17 volts in. So most lead acid batteries will work fine. Pull one out of an old power supply. A lot of people do that. Oh, the backup unit. Just probably powered for days.
I'm just thinking, though, if you're talking about building these relay stations all the way up the coast here, I was thinking about a remote location. Could you have a solar panel? And how big would that solar panel have to be in order to be able to have enough juice during the day to power it day and night?
Yeah, that largely depends on how much you're transmitting, how active it is. So there's like a duty cycle perspective to that. But I mean, that's not uncommon when you're dealing with network, intermittent power use applications. And so you can obviously plan that out and kind of take a first principles approach to what size battery, what size solar panel will I need. I wouldn't imagine it'd be very large. Solar panel, but you could have like a pretty small 12 volt, lead acid or some rechargeable battery, and kind of just trickle charge it. I would imagine you wouldn't need much to put these out. Again, it takes about, I think, roughly on average about 30 milliamps of input current that we've seen. So
when it's not transmitting
from the battery, so when it's not transmitting. When it's transmitting, it's a couple hundred. But again, that's a duty cycle perspective. So yeah, it's pretty low power. You wouldn't need much.
Okay, that's cool. So it still sounds like this is sort of more a hobby than an end goal. I'm just wondering, could someone already take you're talking about solved problems, digital voice, IP traffic, things like that, meshing. Couldn't somebody just take existing software and port it over the top of what you've built in terms of hardware?
Yeah. So actually, Bryce, let me take that one. So the interesting thing there is that there is a missing piece within ham radio, which is that hardware that allows you to do just that. And as John figured out, it's really difficult just to take a normal amateur radio, handheld or mobile rig, and hook it up to a Raspberry Pi and have it do anything more than basic APRS or AX25 at 1200 baud. D-Star, if you have the basic D-Star handheld, you can go up to about 4800 baud with digital data, and that's it. So you're really limited. Even if you did want to port, a digital voice codec over D-Star, you really have to fit it within that. I think all in all, it's about 4800 and 9600 baud. So you're really limited there. Where Faraday fits in right now as a platform, and it's growing to those end goals, but we're providing that layer of wireless communications where you have hardware that works, you have basic software and firmware that interacts with the so if you plug it into your computer, there's actually a little proxy server which is a RESTful interface over Flask, and you can just send data to different ports. And depending on what how those ports are programmed, you can send data between two Faradays or in the local area. And so like my current project right now that I've been working on is I've built a base firmware module that just takes in data from the computer and sends it out to another Faraday. And it's basically a wireless wire and of packets, and I'll soon be taking just a simple voice codec, taking those packets from the voice codec and sending them over Faraday, and then you have digital voice. The Faraday allows you to do that with any data you want. So yeah, if you wanted to just take other software packages and throw Faraday as a layer in between them, that's totally possible. But the biggest difference that Faraday allows you to do is that we have the flexibility of the hardware, which is up to 500 kilobits per second. Right now, I run it mainly at about 38 kilobaud, just because it's easy. And I use a lot of the packet hardware inside of the chip to make it easy. But unlike other ham radio solutions, it's capable of doing much more, and we will. But it is a layer in between that you can send anything you want. It's just a matter of whether you program it to do it.
So I want to jump in and ask, from an FCC perspective, what do we have to do? So let's just say that I order one of these today and they come in. What's the next step between getting the hardware and being able to transmit? So I've already got my ham license. Do I have to check in with someone in my state and claim a slice of bandwidth? Are there any rules about, or do I just look for something that's not being used and jump on it? How does that work?
So from an FCC's perspective, Part 97, you are the control operator of your station. So you are responsible for the proper operation of your hardware. So that's one reason we require that you got to be licensed, because we do want people using these, on the ham band legally. And, so we usually, say, hey, do you have a license? You really need one. It's right on our website. It's, hey, if you buy this, you do need a license. Kind of no different than if you were to buy any of the other kind of ham radio solutions online. So yeah, you wouldn't need to check in. There's no registration. It's essentially equivalent to building your own board. This is one of the benefits that an amateur radio license gives you, is you can experiment with RF, on your own. Like you're allowed to do this because you are deemed, technically competent enough to understand whether or not you are violating a rule. So we've designed it, as to be as best as we can, but we've done quite a bit extensive testing on it. But in the end, being an amateur radio operator, everyone is responsible for their own operation. And we do suggest that people use the frequency. Like there's a frequency, I think it's about 914.5 megahertz that we tend to use for a lot of our development. And in the future, I'm sure we will say, hey, most base stations will be on this frequency, or there'll be some way to find out, or some database of what frequencies are doing what. But you can make Faraday go to any frequency you want within that band, and it will go there. As long as you're operating within the 33 centimeter ham band, you're fine. That's it.
I would like to add in there. I'd like to add in there, John, that also the general amateur radio good practices falls in there, where generally you should you should try to make sure there's nothing else on the frequency. You can look up the general practices, like general frequency allocation, and find out where generally other voice repeaters are, or other digital networks are, and stay away from them. Now, the CC430 does have different options, like carrier sense, so that you can sense that there's signals on the frequency before you transmit. As we were talking before, if you do more frequency hopping spread spectrum, which we don't currently do, but it is capable of doing, then you dissipate your energy over multiple frequencies, and that helps alleviate problems as well. But generally, it falls into just following good amateur radio practices of not misusing. But in the end, amateur radio is very self-regulating, and people will usually tell you if you're doing something wrong, like, hey, try not to do this. This is a problem for this reason, and that's it. And as long as you're cordial and nice about it, people are usually very welcoming and accepting. So yeah, it's really no different than any other amateur radio.
Cool. Is the FaradayRF, is it full duplex or is it just half duplex?
It is half duplex.
Okay. So if we got two of them and both of them together, we could do full duplex.
Yeah, if you want, you might need a diplexer there, but yeah, there's no reason you can't.
Okay.
Yeah, just over two USB ports.
There you go. What about encryption? So 802.11, of course, has encryption built into the standard. How does that work with ham radio?
Yeah. For ham radio, there's no. Well, it's another contested thing in ham radio is technically some people will operate Wi-Fi routers at higher powers with their ham license. There's a whole nother slew of problems that can be associated with that. Like if you check your Gmail over that, like it's technically an HTTPS, that can get really dicey. But things from a Wi-Fi perspective, people seem to say, if you publicly make your password available, you can encrypt it as long as people have access to your password. And that is not necessarily encryption from an illegal perspective. Again, it's kind of hotly debated. We don't currently encrypt at all. I mean, amateur radio, if you're looking for encrypted solutions, amateur radio is not your, play around with ISM, get one of the ISM modules, the industrial, scientific, and medical, part 15, no license required modules, and play with that. Faraday's probably not your solution. But yeah, we kind of steer clear of the encryption. I really am interested in looking at the authentication aspect for ham radio. Actually authenticating. Okay, let's say I have a Faraday on a balloon that's operating in high altitudes, and I want to do a cut down and end the mission, start parachuting down. You want to make sure that whoever sends that command is you. You don't want someone else to do that. So I would love to look at the authentication aspect of that to, make sure that that is being done legally as well as, properly.
Something like a HMAC on the end of each packet. Yeah, that would certainly be interested. Yeah,
so it's actually.
Go ahead.
Oh, I was just going to say that one of the things with Faraday that we're looking to progress in the future is that encryption and authentication issue within ham radio, and saying if we don't get over this and push and say, okay, this encryption is probably not good, but this authentication and this way to do it is good and legal. And yeah, you're not going to be checking, you're not going to be using amateur radio to do your general internet browsing. And that's just from a regulatory perspective. Now, you can definitely port the internet over it, but you have to be very careful what information that you port over there. But we can't let that fear of encryption within ham radio stop progress within the community.
I've wrestled with that question looking at ham radio as well, and that's one of the things that's been problematic towards doing more interesting things. So I'm glad to hear that there are some people trying to make progress there. So I want to ask you one more thing before I give it back over to Randall, and that is something that's always interested me is the old bulletin board systems, and it seems like it would be very nifty to be able to do a bulletin board system over ham radio. Is that something that you've had anyone else interested in? Has there been any work done? Is it possible to do a BBS with Faraday?
Yeah.
So let me take it. Yeah. So yeah. So we've had a few questions about that. It's definitely something, especially for people who look at the, using APRS, like the, AX25 audio frequency shift keying, type solutions. Often we'll ask, if you look on the amateur radio subreddit, a lot of people every now and then will pop up and ask something like that. So it's certainly something that people are interested in. It's sort of a retro perspective, so it's maybe not something that we immediately went out to solve, but it's definitely an interesting and fun solution to have one day. Is it feasible? Absolutely. Faraday's built on, at the moment, it's built on more Flask servers that communicate over localhost. And so we have an application called Proxy that provides the UART connection to the USB over the localhost to other applications. And we have things like telemetry. There's a telemetry server that will communicate with that, decode the packets, and save it to a database and provide you other access to the decoded telemetry. We have another one for just providing a user interface. You could easily write another application that takes in data from Faraday and provides a bulletin board service. So it's just another application. It's, for the most part, there might be a little firmware that's needed in that one, but it's probably mostly a Python or whatever you choose to use to communicate over localhost problem to solve.
I'd also like to add in.
Go ahead. Sorry.
I'd also like to add in that that bringing up a bulletin board system idea is a little bit retro, but it does bring up the idea of store and forward. And one thing that I would like to see within the hobby, and especially within Faraday's development, is the push towards more store and forward. Like, there is no reason why I can't have Faraday on a car. We've already flown it to 30,000 feet on a balloon over California, sending down telemetry. But there's no reason that ham radio needs to stay real time all the time. Like, that we can store and forward, save packets, and hop them between different stations. A really unique and interesting application I'd like to see in the future of Faraday is either telemetry or just general data network where, let's say I do a lot of backpacking. I actually just got back from a backpacking trip. I'm on backpacking and I'm out in the mountain and or something, and I'm not within range of any stations, but here comes a car with another Faraday on it, and we make a connection. I dump some data down to it. It keeps driving. It gets to another town, and then it dumps the data into the town. And now I've made a connection, and you can do the reverse. That's a very interesting, unique application of amateur radio, specifically where ISM probably wouldn't work, because ham radio, we all want to work together. We want to communicate, and that's one of the things that separates amateur radio's wireless medium from the general ISM wireless medium.
Is this small enough that it could fit on a drone?
Oh, yeah. I think we weighed it for the balloon. If you go on our website, I think we put the weight on there for what the actual individual payload was for weight. But I think it's like 30 grams or almost 40 grams at the moment. It's probably less if you take off the JTAG connector.
Yeah,
but,
right. And so
it's pretty light.
Is the frequency at the 33 centimeters, is that more robust than the typical control frequencies and video frequencies that are being used for current drones?
I believe most of that work is done in 2.4 and 5 gigahertz. So it'll be less prone to things like leaves and trees and humidity and stuff like that at 900. 900 megahertz is probably going to act about what like old GSM network for your phone acted like. It's roughly the same frequency. So it'll be about as robust as that was.
So in other words, in no home that I've ever lived in would it reach to.
Ouch.
I love that all these phones have this great technology, and I can walk around down the street, and I could be, playing Ingress still, which I'm still doing. That's another thing that's taking up all my time. But I can't use it inside pretty much any building I'm in. It's crazy. I don't understand how they make it so difficult.
The interesting thing there is most buildings now have the insulation that has like a metal backing, and that blocks a lot of RF, and that's a problem for any radio. But I mean, the interesting thing to note is that, Faraday, there's one Faraday. There's no difference between a base station and one that you use for your projects or as like a little handheld or whatnot. So one of the largest problems within ham radio and advancing ham radio itself is the infrastructure problem. D-Star and a lot of these other networks, the ICOM who really pushed D-Star, they pushed a ton of money into building repeater sites and giving access to clubs at discounts, and to build that infrastructure and make it more of a accessible thing within the hobby. So then you step back and say, well, how does something with a completely open source infrastructure and even hardware, how do you push that within ham radio and make it successful? And the first thing is it kind of has to be a little bit of a business so that we can make the hardware at an economical rate and push it. And secondly, we need to make sure that the hardware and the firmware and the software is able to act as seamlessly as possible, so that I can take this relatively inexpensive radio and put multiple base stations around my town, my city, and with an interconnected network, hop between them, just like APRS right now does. APRS is extremely nimble in that sense, because you can take any old HT at 1200 baud and put it up on the network. Whereas with the D-Star repeater, you're going to be spending a lot more money to do that. So we've taken the approach of make the infrastructure as cheap as possible and easy to use. And that way, you don't need to have every radio cover 20 miles. You can cover if you live in a hilly area, maybe you cover a mile because you're just hitting hills. And that's fine, because your buddy down the street has theirs, and you just hop between them.
Yeah. Yeah, cool. Hey, we're almost out of time, and I hate that when that happens, because I usually have about 20 more questions I want to ask today. No exception, but we do have a question from the chat room. And remember, this is not me asking this. This is Sandman. Where's his name? Where is it? Yeah, Sandman says, who was born first?
I was. Oh, no. You beat me to
You
it.
can't take that from me.
I was. I wanted.
You were supposed
tried
to
to
be
see
first, but I beat you to it by 1 minute.
I wanted to see if you would correct me.
And
you're not
apparently did.
getting away from that.
All right. And on a much more serious note, I understand that maybe I don't understand, but when you're using amateur radio, you have to do station identification from time to time. I forget whether it's every 5 minutes or every minute or something like that.
Every 10 minutes.
Does that have to be done as voice, or can you publish it digitally under known protocols?
It's a very good question, and that's one of the fun things about this project that I've been learning. So there's a number of ways to do it, and that basically boils down to it has to be a non-encrypted and easily accessible form of identification. Since we're using a standard modulation, at the data link layer, so layer 2 of Faraday, we have a local ID of my call sign, and it's sent in ASCII text over DFSK. So there's and all of our firmware is online. So if you ever want to decode it, you can go, whether you have a Faraday or a software-defined radio, as long as you can decode the protocol, it's not encrypted, and it's in ASCII, that's good enough. And I mean, if you really wanted to, I mean, like some digital stations within ham radio used to send digital and then send Morse code. That's really not needed. As long as it's as easily accessible format for your identification, you're okay.
That's very cool. Because I was puzzling about that, because I remembered that there was some sort of ID requirement for all amateur transmissions. Is that sent continuously then?
So the actual requirement is very old school. It's for voice. So it's once every 10 minutes or at the end of your transmissions when you stop talking. So that doesn't really play well with digital, but you can still do that. How we do it is since you want to talk to a specific station or stations in your area, you are likely sending out your call sign with all your packets and to some destination or like a broadcast to the whole area. Every FaradayRF packet at the layer 2 has your call sign in it, so that everyone knows where that packet came from. So every time you send any piece of data, you're always identifying, so there's no problem.
Wow, that is cool. But I guess it's like every packet on a traditional wire has a MAC address. So yeah.
Exactly.
Go ahead.
Yep. I was going to say exactly. So the interesting part about amateur radio is that yes, we could totally do IP, but we have this. Every single person that has their own call sign has their own unique identifier within the FCC. So I can use my call sign KB1LQD, and no one else can use that, and I can just assign some SSID number as well and kind of define a unit, but that's good enough. That actually works really well.
Cool. And I have one final question for Bryce. So what is it you have in orbit?
Oh, yeah, my day job, I work in the aerospace industry. One of the projects I worked on is currently floating around in heliocentric orbit. So I think it's trailing. It might be trailing the Earth, but it'll be there for a couple billion years. So that's fun. Brett and I both helped with the AMSAT, the Amateur Satellite Corporation, ham radio group that does satellites. We worked with a senior design group and built a maximum power point tracker, and that's about to go in orbit. So that's kind of cool. You can see that we actually have the public domain schematics and documents on the Faraday GitHub repo. You can go there and see that. So if you're interested in that as well, but that's almost in orbit.
And Brenton, this is something I normally ask at the beginning of the interview, but I forgot. Where are you talking to us from?
I'm also in Los Angeles.
Oh, so you're both nearby. Okay, I'll wave in your general direction. That's somewhere over there. Okay, all right. I thought maybe you were like in New York or something. I just wanted to. So you guys stay close together, huh? That's weird.
Yeah.
Not the plan. It was not the plan. But that's a whole nother story.
Okay, well, we'll have to do a different show about that. And also, a number of people in the chat room have also suggested that you guys come on the Ham Nation show that's also on the Twit Network. Cool. So we'll get you in touch with them after the show. So anyway, one major final question, then two micro final questions, but mandatory questions according to my audience. So the major final question is there anything we didn't cover that you guys wanted to make sure that we covered today?
So, we right now, as we said before, Brett and I are both hardware engineers, by day. So we're learning from a software perspective. We have our vision. If you read our website or master plan, we have very clear vision of where we want this to go. But we are also it's really fun to learn from people in the community, and the more people that we can get on to kind of help push this project. It's a very infant open source project. So there's quite a bit of help that can be done to shape how we develop software and hardware, how we develop this network. So we really would love to see people chiming in, and we really want to also see more people who aren't currently into ham radio possibly get interested in ham radio, either through this project or something like it. So I think those are the two main goals we really want to see in the next couple months or years from it.
Cool. And Brenton, anything else?
No, Bryce covered it pretty well.
Good.
Yeah, I think I'd just like to state that one of the fundamental reasons that Bryce and I started FaradayRF is because we both love ham radio, and it gave us a lot of it really enriched our lives. And it's how I found electrical engineering and really progressed in it. I had a lot of fun doing it. But I felt a little bit sort of like I hit the end of the wall a couple of years ago, and I was like, I like this ham radio thing. I know Morse code. I've talked all around the world. I've done contesting, and that's great. But I was missing that new relevant digital network that I really wanted to play with, and a means to experiment and learn about wireless communications. And at the core, although Bryce and I started FaradayRF, our main mission is to get more people into ham radio, doing more interesting things, and not only expanding ham radio into other communities and growing it, but bringing other communities back into ham radio, because in the end, we're all in this for the same reasons, which is having fun, learning, and making progress within technology. So at the core goal, that's what we're trying to do.
So do you think you can add video someday to this and call it a Farnsworth?
Oh man!
Certainly add video.
Well, in all honesty, when we were looking at what we should do, these people don't use CC430s and these other similar ICs for digital video or these other more bandwidth hogging protocols, but there actually has been use for that. I found application notes for similar. I think it was a Bluefin, the analog devices kind of equivalent, where they actually made like a 15 frames per second video using a 500 kilobit per second modem, just like this.
Wow.
So it's totally there. It's just that we fit in ham radio where we are, 500 kilobits per second is actually blazing fast for RF. And I mean, it also goes 20 miles when you're in good conditions. So we fit in this niche where we're sort of, it's the consumer market wants to go into, tens of megabits per second or faster. But right now, like we can actually eke out pretty reasonably some video. That's not far-fetched, actually.
It is important to note that.
Go ahead.
It is important to note that the right now, like the most ubiquitous and cheap and easy to access digital network in ham radio is APRS, which is audio frequency shift keying, 1200 baud. I'm not aware of I don't even think you can buy internet that slow these days. I think the slowest internet you can buy is faster than that, which we don't have to go at megabits per second to make an impact. We might as well keep it simple and develop interesting technology, learn, and then, in the future, springboard from that.
And you say that you can't go that slow, but you obviously have never been on Comcast. Okay, anyway. I did that. All right. I went there. Yes, I did. Hey, 2 final questions real quick, guys, because we're almost out of time. Actually, we're over time a little bit already. 2 final questions. What's your favorite text editor, and what's your favorite scripting language? Either of you can start.
You got it, Bryce.
Oh, I got it. Okay. So I'll answer scripting language first. Python, I use it all the time.
I know. Yeah. Okay.
I've seen some other shows. You're probably going to hate me in this one. I tend to use Notepad++. So I don't know.
Sorry.
I don't know.
Sorry.
Hey, it does its job for me. Again, I'm a hardware engineer by trade, so I just usually will use that.
Great. Brenton, same questions?
So I really like C. It is something that I've really grown a liking for. And but my favorite editor, I use Code Composer a lot, but my favorite editor is probably on the Python side, and that's probably PyCharm. It's been my favorite to use so far.
Well, kids these days, they're just not picking up Emacs or Perl anymore. I know. Kids these days. What can I say? Hey, guys, it's been fun. I could go another hour. There's a lot more questions I still had on my list, but we are out of time. Thank you guys both for coming on the show, being the first pair of twins on the show, and talking about FaradayRF, which you obviously both are very passionate about, and your passion came across very clearly. Thanks, guys.
Thank you.
Thank you very much.
Thanks for having us on.
Awesome. That was Bryce and Brenton Salmi talking to us about FaradayRF. What do you think there, Jonathan?
Super show. I don't know if it's these guys specifically, but this sort of project will be the future of ham radio. There are so many outstanding problems and kind of backwards old things in ham radio right now, and this is the kind of shot in the arm that it needs to really be relevant for this day and age. So I'm excited to hear more about what they're doing, and I will probably be ordering some hardware from them very soon.
Cool. Well, let me know how that goes. Well, the good thing about amateur radio is that, a lot of what I'm holding in my hand here, my cell phone, a lot of the technologies there were first experimented with by amateurs and then eventually adopted as a commercial basis. So some of the code that these guys are writing today, and their friends and everybody that's working on the project, may eventually be the basis for some communication protocol that's low power for little repeaters or something like that in the future. So we're always in an exploratory mode here with this kind of stuff, and I'm glad these guys are doing that. So any final words before I run down who's coming up?
No, go right ahead.
All right, there we go. So next week, Pelosa. It's a distributed bitmap index for massive data sets. You want to find out everybody that's over 35 and has a Toyota Civic. Not Toyota Civic. All right. Honda Civic. See, that's why they let anybody do these shows, because apparently I just come up with brand new cars. Anyway, so you have this intersection. You want to get the intersection of all these different binary choices at once, and this is great for huge data sets like that. Magento after that, there's a commerce platform for doing shopping carts. Flutter, I'm very excited about this show. It lets you, in Dart, to build fast cross-platform mobile apps, and I'm really, really getting more and more excited about Dart every day. I'm playing around about a half hour a day with Dart and building up some courseware that I'm going to be giving really soon in Atlanta coming up in September. A whole full hour of why your next language should be Dart. Cockpit, administer your Linux system via the web. Redis, which is the most popular in-memory key value store. Brian Bellendorf is going to join us, a legend in the industry. He's going to talk to us about blockchain technology from Linux Foundation, known as Hyperledger. I saw some presentations on that at OSCON a couple weeks ago. Jenkins, which is the leading CI/CD server. It's a fork of Hudson. We're going to talk also about pitchforking, how forks get made under duress. Containership, which is cross-platform to deploy and manage containers. LibreOffice, where they're coming back to talk to us. They were on 5 years ago, but a lot has happened in 5 years. And speaking of a lot happening in 5 years, we just added to the schedule between last week and this. Kazoo is going to come back. That's a cloud telephony, so it's voice over IP stuff. We do have a very special co-host scheduled for that show because last time Kazoo was on was 5 years ago, and then they were also on about 7 years ago just as the 2600 Hertz project. The co-host I had for both of those shows was none other than our friend Dan Lynch. Well, you might have noticed Dan Lynch has been gone for a long time. He's dealing with some medical issues that he'll probably tell you about. But I got him to be the co-host for this show as well. So it's a tradition. We talk about 2600 Hertz or Kazoo, and we're going to have Dan Lynch back again. He's going to rejoin us, probably not on a regular basis, but at least this show coming up. So I'm looking really, really forward to that. Twit.tv/FLOSS is the homepage for the show. Again, if you have a project that's not on that list, have the project coordinator or a project leader or a community coordinator email me. There's a live stream at 9:30 a.m. Pacific times. It's been on Tuesdays for many, many months, maybe years. I think, yeah, it's been on Tuesdays for quite a while. But we're moving to Wednesdays starting June 28th. So you can come on and talk to us then. If you try to tune in on Tuesday after that, you won't be talking to us because there'll be some other show. You follow us on Floss Weekly on Google+ and at Floss Weekly on Twitter. Follow me at Randall L. Schwartz on Google+ and at Merlin on Twitter. I'm going to be at the Pro Conference coming up in a couple weeks where I'm going to be giving one of these Dart talks. And I'm also going to be talking about Perl's second best practices. I'm going to be at DragonCon in September. That's in Atlanta. That's the one where I have the full hour of the Dart talk I'm going to be doing, and a bunch of other panel stuff using Hacking 101, Hacking 201, things like that. Allthingsopen.org is coming up in October, I think, and that's over in the Research Triangle area. I'm in a 1 day or 2 day conference, and I'm going there as Floss Weekly to find more guests for this show. Although if you look at my schedule right now, I'm booked all the way for about 3 months. So this is actually really, really good, mostly out of having done Red Hat Summit and OSCON, and then a bunch of other people have stepped forward, like Jonathan did, to bring me a guest. So that's all I've got to plug. Jonathan, quickly, anything from you?
I am JP_Bennett at Twitter, as it says somewhere down here.
Yep.
That's about all I've got. I've got a business trip coming next week, but nobody's interested in that because it's not really about open source this time.
That's okay.
So that's it for me.
Hey, Jonathan, thanks for stepping in, and thanks for bringing us the guest this week. This has been a very entertaining show, and I really appreciate that. So thanks again, and we'll see you all again next week on Floss Weekly.